This video is on parallel lines and transversals. I'm going to turn my page. So parallel lines and transversals. I'm going to focus on the vocabulary, basic vocabulary. The first one we're actually going to talk about is parallel lines. Parallel lines are lines that never intersect, so they'll never cross each other. And a transversal is a line that intersects two or more lines at distinct points. The transversal does not have to intersect parallel lines. So to explain what a transversal is, on this picture right here, we do have line M and line N are parallel to each other. One, it says that M is parallel to N, and then we also have these arrows inside the lines that show parallel marks, so that these two lines are parallel. The transversal is a line that crosses through both of these at two distinct points. What that means is that they're actually at two different locations. So if I were to have two lines intersecting like this, instead of parallel, so it doesn't have to be parallel, but if I have a transversal that I think is transversal crossing through here, that green pin is actually only crossing these two lines at one point, right where they cross. So the green would not be considered a transversal. A transversal has to cross the two lines at different points. So if the transversal is crossing parallel lines like it is here, then we actually have the relationships have very specific numerical relationship. Transversals crossing any two lines or more lines already have a very special relationship, but the numerical relationship changes when they're crossing through parallel lines. So to determine the location or the location description, we pick one of each of the words, so alternate or same side. We pick one of those two words, and then we pick one of interior or exterior. So you're going to have a combination of two words most of the time, and most of the time it will be you pick either alternate or same side, and you'll pick either interior or exterior, depending on which one you're looking for. So when two parallel lines are cut by a transversal, what angle pair relationships exist? Now, the angle pairs will actually exist even if they're not parallel, but the numerical relationships will only exist if the parallel lines are cut by a transversal. The first one we're going to talk about is corresponding angles. This is a postulate, and if you remember back from geometry vocabulary, postulate is an accepted statement of fact. So this one has to be true. Corresponding angles are the one type of angle where you actually don't just pick one or the other. Corresponding angles, they have to be on the same side of the transversal. So when it talks about same side and alternate means angles that are on alternating sides of a transversal, and same side means angles that are on the same side of the transversal. Interior means in between the two lines, so in between the two parallel lines. And exterior means on the outside of the line, so on the outside of the parallel lines. So corresponding angles, they have to be on the same side of the transversal, same side, but you're going to have one interior angle and one exterior angle. This is the only type that does this. So corresponding angles, there are some corresponding angles and they have the pairs. It says angle A and angle E. If you notice that these angles actually touch different parallel lines. Angle A touches line M and angle E touches line N. These types of angle pairs that we're going to be dealing with have to touch different parallel lines. So one of them has to touch M and one of them has to touch N. So to have corresponding angles, we have on the same side, and it has to be one is on the inside and one is on the outside. So angle A is on the outside of the parallel line, but it's on the left. So it's basically on the top left. And if you go down to N, line N, angle E is also on the top left. Corresponding angles are actually in the same location, but just on different levels of your parallel lines. So if we have top left here, those are corresponding angles. If we look at angle B is on the top right of the transversal, so top and right, that means that F is also on the top and right. And if you look up here, we have B and F are corresponding angles. So corresponding angles are in the same location, just on different parallel lines. So if we say bottom left, we go bottom left, D and H. D and H are corresponding angles. Bottom right, C and G. C and G are corresponding angles. Now, these will happen even if the lines are not parallel, but what happens because they are parallel is that these angles, corresponding angles, are congruent. These angles, angle A and angle E, are the exact same measurements. That does not mean that angle A and B are, but angle B and F are the exact same measurements. This is the numerical relationship. This is the transversal relationships. The next one we're going to look at are alternate interior angles. This is a theorem, so this can be proven. Alternate interior. So we got to understand again what alternate means. Alternate are angles that are on alternating sides of a transversal. So if a transversal is going up and down, the sides are left and right. So we want to talk about left and right. So one angle has to be on the left, one angle has to be on the right. And these angles, all of these angles that we're talking about with transversals, have to touch different parallel lines. That means that our angles must be non-adjacent. Non-adjacent. They cannot be on the same parallel line. They cannot touch each other. So alternate means one's on the left, one's on the right. And interior. Interior means between the two lines that's not the transversal. So in between them. So the only angles we can talk about are D, C, E, and F. So to think about alternate interior, if we look at this figure right here, alternate means we have to have one on the left-hand side and one on the right-hand side, and they have to be inside. So if we focus on this side, if we focus on angle D, now angle D is touching angle line M, so that means that my other angle has to touch line N. So to be on the other side, it's on the left right now. I have to go to the right-hand side, and I have to stay inside the parallel lines, but it has to touch line N. The only angle that does that is angle F. So angle D and F are alternate interior angles. Therefore, angle C and E are alternate interior angles. However, angle E and angle F are not alternate interior angles because they are adjacent to each other. And if you recall back, you have two angles that are actually forming a line. Those are actually called a linear pair. That's what happens when they're touching the same parallel line. That's why we can't have that. So angle E and angle F are not, I'm just going to write a little note here, angle E and angle F are not, because they are actually a linear pair. They are a linear pair. Now again, the alternate interior angles would have happened even if they weren't parallel, but the numerical relationship we want happens because of parallel. Alternate interior angles are congruent as well. Just like corresponding, they are also congruent. The next one we're going to talk about is the alternate exterior angles. So this goes along with the same thing we just talked about. Alternate has to be a one on the left, one on the right of the transversal. Exterior, that means that they're actually both on the outside of the parallel lines. or the lines in general. So if we look at this figure, we want to talk about left and right, and they have to be on the outside of the line, so on the outside from the parallel lines. So if you pick one angle, if we pick, let's say A, because A is actually on the top, all the way on the top, and it's on the left-hand side. Alternate exterior is on the top left, so it needs to go onto the right-hand side, but they have to be on the outside, and they have to touch different parallel lines. So B is not good because it's touching the same line. So I need to come down to the other parallel line. F is inside, so that's not good, but G is outside. That's what we want. So angles A and G are alternate exterior angles. Therefore, B and H are alternate exterior angles as well. So angle A and G and angle B and H are alternate exterior angles. And again, these have to be non-adjacent. They cannot be touching each other. And again, the relationship will happen regardless of parallel. But what happens because of parallel is the numerical relationship. Alternate exterior angles are congruent as well. So far, we have a lot of congruent angles. Does that mean that every single angle in here has to be the same? No. Could they be? If all of these are 90 degrees, then yes, they would be. But all of these angles will not be the same. You will have two different values. Half of them will be 1 degree, and half of them will be the other degree. So how do we figure out the other degree? That's when we come down to same side interior angles. This time we're talking about the word same side. It means they're on the same side of the transversal. Interior angles. Interior, so they have to be between the parallel lines. So going back to same side, so that means we're going to focus on just one side of the transversal. So I'll just focus on the left-hand side. And then they have to be inside the parallel line, so it has to be in between here. So basically D and E. Now angle D is touching line M, and angle E is touching line N, so that's good. These are considered same side interior angles. Angle D and E are same side interior. Well, angles C and F are also same side interior angles because they're both on the same side of the transversal and inside the two lines. Now, the numerical relationship, which is different, is that these are supplementary. When you have same side angles, they are actually supplementary. That's how we get the other values instead of them being congruent. So if angle D is 30 degrees, then angle E has to be 150 degrees. That's how we get our two angles. And then all of the angles are either 30 or 150. Now there is one other angle pair that we don't have on here. It's if we did alternate interior and alternate exterior, we should have same side interior and same side exterior. So if we write out same side exterior, same side exterior, we need to find the angles that are same side exterior. So following that same thinking process, they have to be on the same side of the transversal. They both have to be on the outside of the lines. So A is on the outside of the line, and H is on the outside of the line. So angle A and angle H. Angle A and angle H. If we find the other one, we would have angle B and angle G, because they are both on the outside of the parallel lines. So we can say angle B and angle G. And again, the question is, what is the numerical relationship? Because these are same side exterior angles, they are still supplementary. These are still going to be supplementary. So, same side Every time you have same side, you have supplementary. Except for when you're dealing with corresponding. So coming back up to corresponding. Corresponding angles are when they're on the same side, but you have one interior and one exterior. This one is where you have to make sure they're in the same location, just on different levels. A and E have to be the same spot, so I can't have A be smaller than E if they're in the exact same location, just on different levels. It's kind of like an elevator. If you're standing here on an elevator, draw a little stick figure here. This is you on an elevator, and you go up the elevator, you're going to be in the same spot when you get off the elevator. But you don't change. You don't get taller or shorter or anything like that. You are still the exact same person from floor 1 to floor 10. So corresponding is very similar to an elevator. It's just going up and down the elevator. But you still have to stand inside the elevator, and you're still standing inside the elevator. You're not just hanging down from it, not holding on to the bottom. You're still in the same location, just on different floors of the apartment or building or whatever you're in. So that's how you can determine with corresponding. So you have to be the exact same person. But same side exterior and same side interior, those are going to be supplementary to each other, because these two angles have to add up to be a line. So those are the relationships for when you have a transversal cutting two parallel lines. That's the numerical relationships. And these happen when your angles are touching two different lines.